QWEL Section 4, Landscape Water. Learning objectives. Understand the concept of a landscape water budget. Have a basic understanding of evapotranspiration. Be familiar with sources of evapotranspiration and weather station information. Understand plant water use classifications. Understand hydrozones and the selection of plants based on various uses and other factors. Learn how to calculate a basic water budget. Learn how to calculate how much irrigation water to apply. Understand key issues for developing a water budget for a landscape site, and examples of water budgets. 1.0 Landscape Water Budget Concept. Understand the concept of a landscape water budget. 1.1 to 1.2 Definition and Purpose. A landscape water budget, or water budget, is an estimate of how much water is needed to maintain a healthy landscape for a given period of time. Often, that time period is a year or a month. Water budgets are an essential tool in planning and managing landscape water use. 1.3 Elements of a water budget. There's 3 elements to a basic water budget: weather, plant type, and area. A water budget is equal to weather times the plant type times the area. 2.0 Evapotranspiration. Have a basic understanding of evapotranspiration. 2.1 Evapotranspiration definition. Evapotranspiration, or ET, is the loss of water to the atmosphere by the combined processes of evaporation from the soil and plant surfaces and transpiration through plant tissues, and is an important component of the water cycle. 2.2 Factors affecting ET. Solar radiation, air temperature, relative humidity, wind speed, soil exposure, and planting density. 2.3 to 2.5 Reference ET. Reference ET, or ETO, is the ET rate of a reference crop expressed in inches. ETO is the ET from well-watered, cool season turf grass maintained at 4 to 6 inches tall. ETO can be measured by using any time period, example an hour, a day, a week, a month, or annually. ETO is the weather component of the water budget calculation. Again, the water budget is weather times the plant type times the area. 3.0 Sources of ETO. Be familiar with sources of evapotranspiration and weather station information. 3.1 Sources of ETO. An accurate and reliable source of ETO is needed. Weather stations obtain data to calculate ETO. Daily ETO data is preferred for more accurate estimations, and historical averages provide an alternative to collecting ETO on a daily basis. 3.2 Weather stations. Weather stations measure solar radiation, soil temperature, air temperature, and relative humidity, wind direction, wind speed, and precipitation. 3.3 EPA WaterSense data. The EPA WaterSense Water Budget Data Finder contains historical peak watering month data, evapotranspiration, and rainfall. 3.4 California CIMMYS. California Irrigation Management Information System, or CIMMYS. It's operated by the California Department of Water Resources. It's a network of over 145 weather stations and has California divided into 18 climatic zones. Free access has been available from CIMMYS from 1989 to present. This chart here describes each of the 18 different CIMMYS zones in California, and it ranges from number 1, the coastal plains heavy fog belt with the lowest ETO in California and is characterized by the dense fog in that area. And you'll see that it's colored on the map in a purple color, all the way down to section 18 here, and that's the Imperial Valley, Death Valley, and Palo Verde, which is a low desert area with high sunlight and considered heat advection. It's a very hot desert-like climate, and you'll see that it will be color-coded accordingly to what is on this map. And then for the Bay Area, you'll see that a lot of that is either in the section 4 or 5, which is South Coast inland plains and mountains north of San Francisco, and northern inland valleys north of San Francisco as well. This chart represents the monthly average ETO by zone, and you can see here that it is color-coded on the left-hand side and numbered from 1 to 18. And as those numbers increase in zone, so does their monthly average ET. And in California, most ET zones have the highest ET month is in July. So you'll see that here it ranges in region 1 of 4.65 inches in July, all the way up to 9.61 for section 18 for the same month. So varies quite greatly. And then over here on the right hand side of the chart, you'll see that this is your total for the year in ET here. Okay, and you'll see on this chart that this is examples of monthly ETO by climactic zone in California. And we have a couple of select different zones you can see across the bottom that are represented here. Zone 1, 4, 5, 12, and 18. And zone 18 would be this top one here in red. And you can see that here's your inches per month over here on the left-hand side. And for July, the average up here is 9-something inches, whereas zone 1 down here on the bottom in purple is just above 4 inches. And the other zones are somewhere in between. So here in California, Santa Rosa specifically, this is a chart that compares ETO to precipitation. And the zone station that we're using in Santa Rosa for the most part is Sims Station 83. And this is an average from 1990 to 2015 as well. So you'll see this blue line here represents the ETO of plants here in this region, which is just above 6 inches. And this red line here indicates how much rain we get in July, which is as close to 0 as you can get. So obviously all of the irrigation needs for the plants will be supplemental for those months. What's interesting to look at on this chart is where these lines intersect is right here in March, and then also over here in October. So what we would consider the irrigation months is mostly right in between those two lines, and needs to be monitored even a little bit more heavily at the beginning of the season and then again at the end of the season. 4.0 Plant water use classifications. Understand the plant water use classification. 4.1 Plant factors. Different plant species require different amounts of water to remain healthy. So it's expressed as a percentage of ETO and referred to as the plant factor, or PF. The plant factor is the plant type component of the water budget calculation. And remember, water budget is weather times the plant type times the area. 4.2 The EPA WaterSense budget tool is broken down into different plant factors. Here you'll see that there's a plant type, and it's broken down into trees, shrubs, ground cover, and turf grass. And then it's broken down into plant factor percentages of ETO, and that's also dependent on the plant type. So trees require approximately 20% of ETO, shrub also 20%, and ground cover also 20%, where turf grass requires 60% of ETO. Medium water use plants are broken down here, and trees, shrubs, and ground cover are all rated at 50% of ETO, where turf grass is 70% of ETO. Then there's the high water use plant category here, where you'll see the percentages for trees is 90%, shrubs and ground cover is 70%, and turf grass is 80%. 4.3 California, WULCOLS. Water use classification of landscape species is a list of approximately 3,500 different plants, and it's broken down into different classifications. So the category is broken down into high, moderate, low, and very low water use plants. And then the given percentages of ETO falls along a range. And we can see that high water use plants is 70 to 90% of ETO. Moderate plants are 40 to 60%. Low is 10 to 30%. And very low is less than 10. Examples of these different types of classifications in the high category would be turf, annuals, willows, and redwoods. Moderate would be many common ornamentals, fruit trees, roses, and perennials. Low would be many of the California natives, Mediterranean, and low water use plants. And then very low would be highly drought tolerant species. This is a chart of the different climatic regions within wool coals. They range from region number 1 through region number 6, region number 1 having a lower ETO and region number high having a higher ETO. So region number 1 is described as North Central Coast, and representative cities that are within that type of region are Healdsburg, Napa, San Jose, Salinas, San Francisco, and San Luis Obispo. Where if you go all the way down to section 6, that would be the low desert, and representative cities would be Borrego Springs, Blythe, Death Valley, El Centro, Needles, and Palm Springs. So much warmer regions. You'll also see in the center here that we have the sunset climate zones that you can refer to if you're more familiar with those. And then also we have the CMIS zones also that are spelled out on this chart for reference as well. So 4.4, other sources of plant water needs. Other places that you can research water needs besides wool coals would be university research, local master gardeners, local plant nurseries, city agency publications and websites, and the Sunset Western Garden Book. 4.5, identifying characteristics. So water conserving identifying characteristics include things like hard leathery leaves, small leaves, waxy or hairy leaves, gray foliage, and fleshy stems and leaves. Many edible plants have a low or a moderate classification as well, such as pomegranate, peach, and plum. 5. Hydrozones and plant selection. Understand hydrozones and the selection of plants based on various uses and factors. 5.1 Hydrozones. A hydrozone is a group of plants with the same water use classification and microclimate assigned to a single irrigation valve. Some of the different variations in hydrozones that might help you decide when you need to build a new one is plant water use classification, root depth, sun, shade, wind, and heat exposure, slope and elevation, soil type, irrigation emission device application rate, and summer dry adapted plants should be on a different hydrozone to those that require more summer moisture. 5.2 Landscape area. The landscape area or hydrozone area is the area component used when calculating a water budget. Remember, water budget is weather times plant type times area. 5.3 Mixed hydrozones. Never mix high water use plants with moderate or low water use plants on the same hydrozone. The highest plant water use classification determines the plant factor for the entire hydrozone. An example is a 500 square foot area irrigated with a single valve that contains 250 square feet of low water use plants and 250 square feet of moderate water use plants. That would be considered as a moderate water use hydrozone. Mixed hydrozones result in water waste and can lead to plant health issues. 5.4 Plant selection. Environmental site conditions such as sun, wind, temperature, precipitation, topography, soil, and pH should all be considered. The mature plant size, the growth rate, and the management characteristics of that plant as well. What is the plant's function? Does it provide shade? Does it block wind? Does it screen? Or is it used for erosion control? And also, what are your regulations? 6.0 Water budget calculation. Learn how to calculate a basic landscape water budget. 6.1 Water budget formula. Now remember, the water budget is the weather times the plant type times the area. But we're going to break it down a little bit farther because we need to convert from inches to gallons. So here's how we do that. So the water budget is measured by the ETO times the plant factor times the landscape area in square feet times 0.62. And that's a conversion factor to get you from inches to gallons. 6.2, water budget examples. So here we have a 1,000 square foot landscape. We have a plant factor of 0.8, and we have a peak monthly ETO of 6 inches. So here we're going to take our formula and break it down. So we have 6 inches of ETO. We have our plant factor of 0.8. We have our landscape area of 1,000 square feet that we now are going to convert into gallons, which equals 2,976 gallons of water is estimated to be needed to irrigate that particular area. So now we're going to take a look and see what it looks like if we were to use plants that have a low water use plant factor. So here we have the same exact area. The only thing that we're changing in this equation is right here, which is the plant factor. So being that it only requires 20% of ETO, we're going to be using the same formula of 6 times 0.2 times 1,000 square feet converted to gallons, which equals 744 gallons, which is quite a savings over the 2,976 gallons. 6.3, here are a couple of California examples. So this is the approximate water budget range for a 1,000 square foot landscape in California, which is dependent on the plant factor of whether it's high, moderate, low, or very low. So here you can see, here are the various categories, and over here is the associated plant factor multiplier that goes with it. And then here we have the annual ETO in inches that ranges from 32.9 to 71.6, which is quite a spread. California is pretty unique that way. So here we have on the right hand side the approximate water budget in gallons for high water use plants is going to range anywhere from 16,000 to 35,500 gallons annually, where moderate use plants are 10,000 to 22,000 gallons. Low water use are 4,000 to 9,000, and very low is 1,000 to 2,000 gallons per year. 7. Irrigation water requirement. Learn how to calculate how much irrigation water to apply. 7.1. Effective precipitation. So rainfall reduces the need for the supplemental irrigation. Effective precipitation, or EP, is the amount of rain that enters the soil and is available by plants. EP is less than total rainfall due to factors such as runoff and deep percolation. 7.2. Irrigation efficiency. When using an irrigation system, it's necessary to apply more water than required by the plants to make up for the irrigation system inefficiencies. Two different metrics are commonly used to estimate how much additional water to apply to account for these inefficiencies. Irrigation efficiency, or IE, is a metric that reflects the amount of water that is beneficially used by the plants compared to the amount of water that is actually applied by the irrigation system. Distribution uniformity, DU, is a different metric that provides a measurement of how evenly the water is applied to a hydrozone. Some water budgets use IE and others use DU, which is covered in detail in Section 7, Irrigation System Auditing. 7.3, Irrigation Water Formula. So here you'll see the formula for irrigation water is equal to weather times plant type minus rain times the area divided by efficiency. Make sure that you're paying attention to your parentheses and your brackets in that formula. So because irrigation water is measured in gallons, we need to make sure that we incorporate that 0.62 conversion factor to get from inches to gallons. So here we have ETO, the reference evapotranspiration in inches. PF is for plant factor. EP is for effective precipitation in inches. LA is for landscape area in square feet. IE is for irrigation efficiency, and then 0.62 to convert us back from inches to gallons. 7.4, irrigation water requirement example. So in this example, we are going to be using 1,000 square feet of landscape. Our plant factor is going to be 0.8. Our peak monthly ETO is going to be 6 inches. We're going to have an effective precipitation of 1 inch, and our irrigation efficiency is going to be 70%. So again, follow this formula along with me and where we plug all of these in. So we have 6 is the ETO, we have 0.8 as the plant factor, minus the 1 inches of effective precipitation. Then we're going to multiply that by 1,000. Then we're going to divide that by the irrigation efficiency of 0.7. And then in the end, to bring it from inches to gallons, we're going to multiply it times 0.62. And the result is 3,366 gallons per year. So now we're going to change that up a little bit more. And the next example down here is basically the same exact situation. It's still 1,000. It's still a plant factor of 0.8. It still has ETO of 6 inches and effective precipitation of 1 inch. What has changed and is unique in this particular equation is this right here, and that is the irrigation efficiency is 0.6. So it's 60%. It's not quite as efficient as the top example, and we will walk through and see what effect that has on it. So same equation, only the difference is right here, where we'll be dividing it by 0.6 instead, and the result is 3,927 gallons of water used instead of the earlier number of 3,366. So you can see the efficiency changed by just 10%, had an increase of almost 600 gallons per year. So you can see by making some changes in your irrigation system and trying to make system improvements that you can cut back on your water use by doing that. 8. Water budget issues. Understand key issues for developing a water budget for a landscape site. 8.1, water budget challenges. So some of the things that you might run into when you're trying to come up with a water budget is you need to know what your reference ET is so that you have a baseline to work from. And is it reliable and is it timely? So how old is this data that you're looking at? And does the available ETO data accurately reflect the site conditions? So as far as site conditions, is it it's more of a microclimate situation? Is it windy? Is it extremely sunny? Is it extremely shady? Is it on a slope? And so there's different things that you have to keep in mind. Even if you do have accurate ETO data, is that data representative of your specific site? And are you using current ETO versus historical averages? So keeping that in mind, sometimes historical averages can get skewed if you had some anomaly years where it was excessively high or excessively low that could throw off your historical average versus using current live reference evapotranspiration. Additional water budget challenges might be determining the plant factor. It might not be as straightforward as it seems. You might choose a plant that isn't available on one of the lists that identify plant factor, and so you might have to spend a little bit more time figuring that out. There's new landscapes versus existing landscapes, how much water they need, and without having an established root structure, you don't have to irrigate as deeply, so that might change your budget calculations around a little bit. You do need some horticultural knowledge to identify plants, especially if you have inherited a system that has plants there already and that you didn't choose these plants. You're going to have to figure out what kind of plants they are so that you can identify their plant factors. And then also having to deal with mixed hydrozones and how you deal with that if you break them up into new hydrozones, or if you try to supplement, irrigate the plants that have a higher water use in them, or are you going to over irrigate the plants that are low water use within that hydrozone instead? So other things that you have to keep in mind is the irrigation landscape area needs to be known or measured. So because the area in the equation is an important component of it, you have to make sure that you measure that area and you know how large that space is. And then you identify whether it's new or existing. If you're doing a total area and you're measuring it, you have to make sure that you exclude the hardscapes and the unirrigated areas. So if you have some batches of plantings within an area, but you also have some bare areas with no plants, that is, you need to make sure that you're not calculating that into your areas being irrigated. So some of the tools that you can use to help you with this is aerial imagery. Oftentimes there's software that you can use where you can have a measurement tool that you can measure the area, especially if it's an odd shape. Sometimes that's kind of handy to have. You'll need a tape measure, a measuring wheel, or measuring your pace, which isn't quite as accurate, but if you're not sure what your pace is, you should try it out sometime by having a long tape measure handy and by pacing it off. Visual estimation is not an effective method as far as guessing. So you don't want to do that. You want to have some sort of way of accurately measuring this because every square foot counts. So you can use basic geometry, and other methods can be used to estimate the areas in the field. If you're not really sure how to measure an irregular shaped area, you can Google that and look it up. But breaking things down sometimes, an entire area into smaller shapes, you may have some triangles that you can measure off and then add them to rectangles to come up with the entire area that you're working with. 9. Water budget examples. Here are some examples of a water budget. 9.1 Examples of water budgets. Water budgets are typically used in regulation and rating systems to compare a water allowance or not to exceed amount, or a water requirement or estimate of how much irrigation water is needed. So irrigating a landscape to a water budget requires the manager to take regular water meter readings to ensure that the amount of water applied does not exceed the budget. So that's something that can be done on frequently or a little less frequently, but a good way to do it is think of it as the first of the month to go out and check the meter and make sure that you are watering according to your budget and current ETO. 9.2 to 9.5 Examples of water budgets. The EPA WaterSense water budget tool is used for new homes to receive the WaterSense label. In California, we have the Model Water Efficient Landscape Ordinance, or MWELO, and that applies to new and rehabilitated landscapes in California. There's a Simplified Landscape Irrigation Demand Estimation, or SLIDE, which is a widely accepted method for existing landscapes. And in California, we have the CLCA Water Management Certification Program. It's used by the CLCA certified water managers to manage landscapes to a water budget. 10. Landscape water review question. What is a landscape water budget, and what are the 3 elements of a basic landscape water budget? True or false? ET changes as the weather changes and is affected by factors including solar radiation, air temperature, relative humidity, and wind speed. What does ETO stand for? The plant factor is expressed as a percentage of what? Name a few identifying characteristics of a low water use plant. What is a hydrozone? How do you calculate a basic landscape water budget using ETO, the plant factor, and the landscape area? What's the difference between the basic landscape water budget and the amount of irrigation water to apply? California focus. What does CMIS stand for? California focus. What is the peak irrigation month for most climate zones in California? California focus. What does WCOL stand for?